Hey class. Okay, let's talk about chapter 2. Chapter 2 is entitled Environmental Systems, and it has a lot of information. Some of it seems like it doesn't even relate, but it's setting a foundation for you so that we can proceed to other chapters and you'll get it. So most chapters are straightforward, like oceans or forests, and obviously it's like, okay, I get it. The water, the trees, the sun, I get it. It's a forest. This chapter is a trip. It talks a little bit about chemistry, a little physics, some other stuff. But again, it's necessary to understand these simple concepts so that we can proceed. So the first thing that chapter 2 does is introduce us to the Chesapeake Bay problem. What happened? Well, the natural ecosystem collapsed due to human impacts. And a very desirable and profitable oyster fishery collapsed with that ecosystem, so it impacted humans. The main cause was pollution from agriculture, industry, and cities. The pollution led to eutrophication. That's a word you need to know. And basically, eutrophication is when too much nitrogen and phosphorus enter a waterway. They cause a phytoplankton to bloom. And when the phytoplankton dies, it sinks to the bottom of the water where microbes decompose them. And as they're decomposing them, they're using oxygen. And basically, there's not enough oxygen then left for anything else to survive. So things like fish and oysters just die, and the ecosystem has collapsed. So in the case of the Chesapeake Bay problem, the total cost to Maryland and Virginia was approximately $4 billion in about 30 years. So that's significant to people's well-being, and that's when people start really paying attention when it hits them in the pocket. Not just that the ecosystem isn't doing well, but now it's impacting me as a human. So they also talk about how they're restoring the Chesapeake Bay, and they're making some success. And we'll talk about that later, or I may ask you in your homework to tell me just how they went about doing that. So the take-home message for chapter 2 is that natural environmental systems exist and that humans can and have impacted those systems on a global-wide scale. It's not even a debate. So I'll remind you that you don't need to know everything in chapter 2. In this module, I will list out what definitions and processes that you should know for the class. And since this is a large chapter, I'm going to include a couple of videos to introduce you to the material, and I'll talk about them in the order that the text presents them as well. Okay, so a system is described as a network of relationships among parts, elements, or components that interact and influence one another through the exchange of energy, matter, or information. That's a lot to swallow. But it's not rocket science, and that's in your textbook, so you can see that for yourself. So there's many ways to describe natural systems. For example, the lithosphere is the rock under our feet. The atmosphere is the air that surrounds the planet. The hydrosphere is all the water on the planet. And these are all different systems that can be delineated to explain what's involved and how do they all interact. So just skip forward really fast. The feedback loops that they talk about in the text, there's two of them, a positive feedback loop and a negative feedback loop. So see figure 2.1 for an illustration. Basically, a negative feedback loop will stabilize a system, and a positive feedback loop will push it more towards the extreme. So let's talk about a negative feedback loop, such as your body. If you get hot, your brain tells your body to sweat and to seek shade, and you become cool. If you get cold, your brain tells your body to shiver and wear more clothes, so you get warm again. So this is a negative feedback loop. If it goes this way, we pull it back this way. If it goes that way, pull it back this way. And we have what's called dynamic equilibrium. That's in the text. And that is what our bodies are. They're a little warm, a little cold, but it's a little dynamic, but it's equal. And the constant internal environment of our bodies is called homeostasis. So let's talk about a positive feedback loop, which drives things to extremes. For example, the hotter something gets, the hotter it becomes, making it hotter, and then it gets hotter again. That's a positive feedback loop. The book shows melting ice in the Arctic due to heat, which exposes the earth, and liquid water, which absorbs more heat, which makes it warmer, which melts more ice, which absorbs more heat, which makes it warmer. That is a positive feedback loop pushing those systems towards extremes. Okay, that's enough for this video. It takes us to about page 30. Please proceed to the next.